This is mathheals.com, where you can find more links to YouTube math videos and computer science. And let's take a look at the area of a region bounded by two graphs. Now let's talk about the idea of this. You're going to have one graph up here, and you'll have another graph down here. And you're trying to find the area bounded. And maybe we're saying between this x value and this x value. So we're trying to find this right here. This is going to be our graph above. And this will be our graph below. And the setup on it will be we'll be going from some kind of x value to some kind of x value. I'll just say a to b. And we'll have our graph above minus our graph below. So that's going to be our setup on these problems. Now, in business calculus, we don't get into it in a whole lot of depth, but you can also have where instead of in terms of everything in terms of x, you could have everything in terms of y. Now, sometimes we'll be given these x values, like it's going from 2 to 10 or something like that. Sometimes we have to find it ourselves, the points of intersection. So, and we'll talk more about that. But remember, graph above minus graph below. Now this one says find the area of the region. Well, the f of x equals square root of x, that's this graph right here. So it's going off like that. The g of x is equal to x to the third is this one right here, if you remember that from college algebra. Well, it's kind of obvious looking at it what the point of intersection is, but let's find it just to show the technique. So we're going to find the points of intersection. To find the points of intersection, you set the functions equal to each other. So I'll set square root of x is equal to x to the third. Well, we got a square root, so you take both sides of the second power. You raise both sides to a power equal to your index. We get that, and this gives us x. And over here, when you raise an exponent to another exponent, you multiply them together, so that gives us x to the 6. Now I want to get everything over one side, so I'll take the x over. And I want to factor this. I'll factor out GCF first of x, and that gives us x to the 5th minus 1. Zero factor property from college algebra. You set each factor equal to 0. So we can set x equal to 0, and x to the 5th minus 1 equal to 0. Now this is one point of intersection here. On this one, I'll take the negative 1 over, it becomes a positive 1. From college algebra, we had, let me write this as 5 over 1. We could raise both sides to a reciprocal of the power. This is 5 over 1. We'll take both sides of 1/5 power. And those 5s would cancel. And we got x is equal to 1 to a power, which is just x is equal to 1. Well, that was kind of obvious. 0, 1, looking at it. Now, I suppose since this is kind of convoluted here, it might be hard to see that. So anyway, that verifies what we already know. Because maybe it's not 1. Maybe it's 0.9. Don't know. Okay, so our form is going to go from 0 to 1. Graph above minus graph below. Well, graph above is this square root of x. So we'll put that first, minus the graph below, which is the x to the third. dx. Okay, so this will be 0 to 1. This is x to the 1/2 minus x to the 3rd. Add 1 to our power and divide by our new power. And add 1 to our power here and divide by our new power. Well, 1/2 plus 1 gives us 3/2. Let's try that again. There. And this would be 3/2 here, minus 1/4 x to the 4th. Remember, if you got a single fraction downstairs, you flip it and multiply times your top part. So this becomes 2/3 x to the 3/2 minus 1/4 x to the 4th. Well, now we're ready to plug in our numbers. So I'm going to have 2/3, 1 to the 3/2 minus 1/4, 1 to the 4th, minus, and then we'll plug 0 in, 2/3 times 0 to the 3/2 minus 1/4, 0 to the 4th. Well, these 0 to the 3/2 is 0 times 2/3 is 0. 0 to the 4th is 0 times 1/4 is 0. So all that drops away. Now 1 to any power is 1. So this becomes 2/3 minus 1/4. I get a common denominator, which would be 12. So multiply the bottom part here by 4 and multiply the top part by 4. So it becomes 8/12. Here, multiply the denominator, the bottom part, by 3, and multiply the top part by 3. So our answer would be 5/12. Now to check this, you can plug this in your calculator. It won't give us the fraction, unfortunately. I'm going to press y equals clear. Clear. I was making up some problems there. Okay. So you press y equals, press clear. And then we want to put in square root of x. So second x squared, x key, closing parentheses, minus x to the 3rd. Do a second trace. Actually, I may have to do a zoom first. Let me press zoom. And choose 6. That sets a standard viewing back. Okay, now I'll do a second trace. I want to choose my integral one. On mine calculator, it's number 7. Lower limit goes from 0 to 1. So 0 inner, then upper limit 1. And I get 0.4166813. The question is whether that's 5/12. So let me exit out. Do a second mode. And 5 divided by 12. That's not quite what we got, was it? Let me see. Second trace and number 7. Now I know I did it right, but not to be pompous or anything, but I know the calculator come up with rounding issues, and approximation issues. So that's what that is. So that's interesting, but obviously we're correct. So let me save that. Area of a region bounded by 2 graphs. Area of a region bounded by 2 graphs, page 01.pdf. Okay, let's look at our second problem. Got f of x is equal x to the 3rd minus 4x, and g of x is equal to 0. Now, looking at this is kind of obvious. I mean, I'll find points of intersection just to give us some practice, but obviously it's -2 here, 0 here, and +2 here. And going from -2 to 0, you see how the curve graph is above the 0. That's y is equal to 0, which is the x-axis. So here it's above. Then at 0, x equals 0 that is, it switches, and the curve graph is below y is equal to 0. So it's below here. So we're going to have two separate integrals when we set this up. But let's first find our points of intersection, just to verify it. So we're going to set x to the third minus 4x equal to 0. 0 factor property, get 0 one side, you factor the other side, so we'll factor out to GCF, which is x, and that gives us x squared minus 4. Difference two squares, two terms of minusing it, so that gives us x times x plus 2 times x minus 2 equal to 0. Again, the 0 factor property says you get 0 one side, you factor the other side, you set each factor equal to 0. So set x equal to 0, x plus 2 equal to 0, and x minus 2 equal to 0. And we got 0, -2, and +2. No surprise. We could look at that and see that. Now, having the graph really does help on the setup on these. So it looks like from -2 to 0, the graph that's above is our curved one, which is the x to the third minus 4x, minus the graph below, which is the 0. Then from 0 to 2, the graph that's above is this 0, minus the graph that's below is our x to the third minus 4x. Well, 0, I just put there to really emphasize it. The graph that's above minus the graph that's below. The graph that's above minus the graph that's below. 0 drops away. So this one right here, we actually let me write it down again. That gives us x to the third minus 4x dx. And this over here, remember a negative out in front of your parentheses flips the sign of everything inside. So that becomes a negative x to the third plus 4x dx. Okay, so we're going to add 1 to our power. So we got 1/4 x to the fourth minus, add 1 to our power, divide by our new power on both of them. 0, -2, plus, same thing here. So we got -1/4 x to the fourth plus 4/2 x squared. We're just adding 1 to our power, dividing by our new power. Which gives us 1/4 x to the fourth minus 2x squared. And same thing here. We got -1/4 x to the fourth plus 2x squared. And now we're ready to plug in our numbers. So in this first one, we're going to plug in 0. So we've got 1/4 times 0 to the fourth minus 2 times 0 squared minus, and then we got 1/4 times -2 to the fourth minus 2 times -2 squared plus, and then this one. So we got -1/4 2 to the fourth plus 2 times 2 squared minus, then we'll plug in 0, -1/4 times 0 to the fourth plus 2 times 0 squared. Okay, well 0 to the fourth is 0 times 1/4 is 0. 0 squared is 0 times 2 is 0. 0 minus 0 is 0. That drops away. So then we have our negative. -2 to the fourth is 16. Divided by 4 is 4. Negative 2 squared is 4 times negative 2 is negative 8. Now this 0 also drops away, so we got this one. 2 to the 4th is 16, divided by 4 is 4, so we got negative 4. And 2 squared is 4 times 2 is 8. Well, this gives us negative 4. And negative 4 plus 8 gives us 4. And here a negative negative gives us positive 4 plus 4, which gives us 8. And that's our answer. Now one thing I want to point out on this one. Now this is an odd function. Not odd, just looks weird. But odd as in terms of its symmetric to the origin. You notice that this area on the left side is equal to this area on the right side. What we could have done is just took the integral from 0 to 2, just to this right side, and then multiplied our final answer by 2. You can use symmetry to help simplify some of these problems. Now, a lot of people don't remember even and odd from college algebra, so I'm going to do the lawn setup like this. But again, if you remember even and odd, it does save you some work. And if you have no clue what I just said, then just do it like I just showed you. Okay, let's look at our next problem. It says sketch a region bounded by the graphs of the functions and find the area of the region. Okay, so we got y is equal to x squared plus 3x plus 2, and y is equal to 3x minus 5. X is equal to negative 1, and x is equal to 2. I'm going to sketch these on our calculator. So I'm press my y equals, press clear. My first function, x squared plus 3x plus 2. And on y2, I'll down arrow to y2, I'll put the 3x minus 5. Let me just press graph, see what I get. Okay, so we get that. And then it's from negative 1 to 2. From negative 1 to 2. Okay, so what our sketch looks like. Doesn't that be precise? Like that. X equals negative 1. Well, let me put that in red. Not, like I say, not that it needs to be precise, but there's somewhere around negative 1 and 2, I don't know, somewhere here. So we're trying to find this region right here. Well, it's a lot easier when they give you the x values like this. You don't have to find your points of intersection. It's going to go from negative 1 to 2. The only thing you have to determine is which one's above and which one's below. So this is going to go from negative 1 to 2. Obviously, this curved one, our x squared, is above this. So our graph above, and then our graph below. So this is going to be x squared plus 3x plus 2 minus our graph that's below, which is 3x minus 5 dx. So this becomes x squared plus 3x plus 2, and a negative out in front of your parentheses flips the sign of everything inside. So it becomes negative 3x plus 5 dx, which gives us 3x minus 3x drops away, 2 plus 5 gives us 7 dx. Okay. So we're going to add 1 to our power, divide by our new power. So that gives us 1/3 x to the third. And if you just got a number, remember you put an x next to it. So 7 becomes 7x. And now we're ready to plug in our numbers. So I'll put 2 in. So I got 1/3 times 2 to the third plus 7 times 2 minus, and then we'll plug in -1. So 1/3 times -1 to the third plus 7 times -1. 2 to the third is 8, so that gives us 8/3. 7 times 2 is 14, minus -1 to the third is -1 times 1/3 gives us -1/3. 7 times -1 is -7. Negative flips the sign of everything inside, so it becomes a positive 1/3 plus 7. Now 8/3 plus 1/3 gives us 9/3. 14 plus 7 is 21. 9 divided by 3 is 3. 3 plus 21 gives us 24. And let me open my window. My wife's got the heat on. It's killing me. There we go. Now this is a little bit tricky to test. You know, it might be easier just to plug it in after you've simplified it, assuming you feel comfortable with your basic math here. So let's do the x squared plus 7. So we'll clear out y1, y2. Then I'll put in x squared plus 7. Second trace, and choose our integral. And then -1 to 2. So put -1 in from our lower limit, enter, put 2 in from our upper limit, 24. Now that does not check that we did our setup correctly. Now if you come up with a negative area, then you know you'd set it up wrong. That's kind of a big indicator. But we have to trust that we did our setup correctly for the verification. And once you work a few of them, you'll get comfortable with it. It's pretty easy. Just looking for above and below. Okay, let's look at our next problem. We got y is equal to x squared minus 5x plus 2, and y is equal to 2 plus 3x minus x squared. Well, this one doesn't give us any points of intersection, doesn't give us like our lower and upper limit. So we're going to have to find it. We're going to have to find our points of intersection. And we do that by setting the two functions equal to each other. So I got x squared minus 5x plus 2 equals 2 plus 3x minus x squared. Now I want to get everything over one side and hopefully factor. So I'm going to take everything that's over on the right side and move it over to the left side. Remembering to change signs of everything. So negative x squared becomes a positive x squared. We've got a minus 5x, and the 3x becomes a negative 3x. And then we've got 2, and take 2 over, and becomes a negative 2. Well, x squared plus x squared is 2x squared. Negative 5x, negative 3x is negative 8x. 2 minus 2 drops away. Now this is pretty easy to factor. We just factor out GCF, which is 2x. And that gives us x minus 4. Zero factor property. You get 0 one side, you factor the other side, you set each factor equal to 0. So I set 2x equal to 0, and x minus 4 equal to 0. Now here I divide both sides by 2, and I get x equals 0. And here I take negative 4 to the right side, and it becomes a positive 4. So these are going to be our POIs. Now let's graph this and see what it looks like. So press y equals, clear out whatever's there, and y1 we'll put our first one. So we got x squared minus 5x plus 2. And our second one we'll put 2 plus 3x minus x squared. Well, most of these are probably going to be pretty easy where you can tell which one's which. But let's say you can't. You're not comfortable with functions and so forth. If I put my cursor up on the line Y1, and I press my left arrow key until it's on the slash in the very first position here. So again, you keep pressing the left arrow key. You can't do it too many times, in case you're wondering. And we're going to press enter one time. That'll make that a thick slash. So that's our first one. Thick. Okay, now if I graph it, let's visually see if our points of intersection make sense. We said 0 and 4. Well, 0 obviously makes sense. 4, 1, 2, 3, 4. Yeah, that probably looks good. You can actually use your calculator to find the points of intersection. If you have one of them on Y1, one of them on Y2, you can do second trace. You can choose intersect, number 5. You can press enter on first curve, enter on second curve, and for your guess, put like 5 in. You're inputting an X value close to where you think the answer is. And then press enter. And see how it comes back and tells us the intersection is X equals 4? Well, that confirmed this right here. And I could do it again to get this other one. So I could do second trace and choose intersect. Enter on first curve, enter on second curve. Let me put 0 in. And it comes back and tells us X equals 0. So that confirms what we just found algebraically. Okay, let's do our setup. 0 to 4. And again, we're looking for our one that's above. And it's going to subtract from the one that's below. Well, this is the one that's above, the one that's not thick. This was a thick, so it's this one. So we got 2 plus 3x minus x squared minus the one that's below, which the one that's below is the thick line here, which is the x squared minus 5x plus 2 dx. Now to reset that that thick slash you see there. If you press y equals, on a lot of calculators, not all of them, but if you press clear, it'll clear out that thick slash. On mine it doesn't. I got the newer software for the TI-84 on this. If I press my left arrow key, put my flashing cursor on the slash, and you press enter, becomes the upper right hand triangle. Enter again is the lower left. The next two are circles. Next one's a dotted line. And then if I do it one more time, it changes back to normal slash. And then you can right arrow over and you're back to where you were. I wish Clear fixed it on the newer TI-84s, but it doesn't. I think it's a bug. It's probably they probably call it a feature. Okay, so let's work this one now. So I got let's see, 2 plus 3x minus x squared. Remember, a negative out in front of your parentheses flips the sign of everything, so that becomes a negative x squared plus 5x minus 2 dx. Well, we got negative x squared, that's negative 2x squared. 3x plus 5x is 8x. 2 minus 2 drops away. Let me just double check that. Negative 2x squared, 3x plus, okay, that's right. So now we're ready to apply our formula. Remember, if you got extra power, you just add 1 to your power, divide by your new power. So that gives us negative 2/3 x to the third plus 8 over 2 x squared. 4 to 0. Which gives us negative 2/3 x to the third. 8 divided by 2 is 4, so we've got 4x squared. Okay, now we're ready to plug our numbers in. So we got negative 2/3, 4 to the third, plus 4 times 4 squared, minus, 0 doesn't do anything, but we'll go ahead and put it in here to show it. There we go. Of course, 0 to the third is 0, times negative 2/3 is 0, 0 squared is 0, times 4 is 0, so that all drops away. Okay, 4 to the third, 4 times 4 is 16, times another 4 is 64, times negative 2 is negative 128 over 3. 4 squared is 16, times 4 is 64. get a common denominator. Rewrite 64 as 192 over 3. And 64 thirds? I'm not very good with basic math. Let me see. Exit out, second mode. 192 minus 128. 64. Okay. Assuming no basic math error, then that's our answer. Now again, to test this, I probably want to do the on the calculator, just my basic math. Probably want to do this one right here, simplest. But that's assuming we combine together like terms correctly. Okay, so I'm going to come to my y equals, clear out everything that's there. Okay, then we want to put in negative 2x squared. 2x squared plus 8x. And I'll do second trace. And I want to choose my integral one, number 7 on mine. And then I want to go from 0 to 4. So do 0 for my lower limit, enter, and 4 for my upper limit, and then enter. 21.33. Does this look like 21.33? Yeah, it does. So that checks. Save that. Let's look at our next problem. Grab a drink here too. Okay. Sketch region bounded by the graphs. Find the area of the region. So we got y is equal to the fifth root of x, and y is equal to x. Well, let's find our points of intersection first. So I'm going to set the two equal to each other. So the fifth root of x is equal to x. Now, remember when you got a radical, you get rid of the radical by raising both sides to a power equal to the index. So we're going to take both sides of the fifth power. When your index matches the power, they cancel each other away. So here we got x, and here we got x to the fifth. Now we want to get everything over one side. So I take the x over, becomes a negative x. Then we want to factor the right side. They both have a GCF of x in common, so I'll pull that out. And that gives us x to the fourth minus 1. Now this actually factors more. It's a difference of two squares. So this factors as x squared plus 1 times x squared minus 1. Which factors again. X squared minus 1 is, again, a difference of two squares. So this is x plus 1 times x minus 1. Okay. Zero factor property. Get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set x equal to 0, x squared plus 1 equal to 0, x plus 1 equal to 0, and x minus 1 equal to 0. On this one, if I take the 1 over, it becomes a negative 1. We're going to end up with an imaginary number, which doesn't do us any good. So you can forget that one. Here, I'll take the 1 over, it becomes a negative 1. Here, I'll take the negative 1 over, it becomes a positive 1. So these three right here are our points of intersection. Well, let's take a look at the graph of this and see how in the world that ties to these points of intersection. I'm going to go to my y equals, clear out what I have there. I'm going to put the fifth root of x on y1. So I'll put my 5 in first, put my index. Then I'll press math. And I'll choose the fifth one, the one with the radical symbol with an x. I'll put a beginning parentheses, x, closing parentheses. down arrow, and our other one is x. So put the other graph here. Now, if you need to make one of them bold, then do it. I don't need it because I know what y is equal to x is. That's a line. So let me press graph. There's our fifth root, and there's our second one, our line. If you watch it while it's graphing, it does y1 first and y2 second, so it's easy to see which one's which. I can't see this though, so if I press zoom, I can choose zoom in, number 2. And it's waiting for me to do something. The flashing cursor is in the middle there. I'll just press enter one time. Okay, and I can see that now. So it looks like there's -1. Here's +1. Excuse me. There we go. You can see a better picture by looking at this. Does that look like it's symmetric, by the way? These are both odd functions, so I could use symmetry and only go from 0 to 1 on this. But again, if you don't see it, I just want to show the setup. Okay, so this is going to go from -1 to 0. And from -1 to 0, it looks like the straight line is above. Straight line is the x. So I'm going to have x minus the fifth root of x dx. And then at 0 it changes, and it's going to 1, because it has to match our points of intersection, our limits here. From 0 to 1, it looks like this curvy part is above, which is the fifth root of x minus x. Because x is a straight line, which is obviously below. Okay, so that's our setup. So let's go through and find this. Well, I'm going to rewrite this as x to the 1/5 power dx, and this one will be x to the 1/5 minus x dx. Now we'll add 1 to our power, divide by our new power, so that gives us 1/2 x squared minus x to the 1/5 plus 1 divided by 1/5 plus 1. And same way here, this will be x to the 1/5 plus 1 over 1/5 plus 1 minus 1/2 x squared. So it'll give us 1/2 x squared minus x 1/5 plus 1. 1 is like 5 over 5, so that gives us 6/5 over 6/5. And this one would be x to the 6/5 over 6/5 minus 1/2 x squared. Remember, if you have a single fraction downstairs, you flip it and multiply times your top part. So we're going to have 1/2 x squared minus 5/6 x to the 6/5. And same here, we'll have 5/6 x to the 6/5 minus 1/2 x squared. Well, now we're ready to plug in our numbers. Even though zeros are don't mount to anything, I'm going to go ahead and put them in here just so you see it. So we got 1/2 times 0 squared minus 5/6 times 0 to the 6/5 minus, then we'll plug in -1. So we got 1/2 times -1 squared minus 5/6 to the -1 to the 6/5 power plus, and then we'll plug in a 1 here. So we got 5/6 1 to the 6/5 minus 1/2 times 1 squared minus, and we'll plug in 0. So we've got 5/6 times 0 to the 6/5 minus 1/2 times 0 squared. Okay, these zeros all drop away. Negative 1, this is negative out in front. Negative 1 squared is positive 1 times 1/2 is 1/2. Now negative 1 to the 6/5. I could plug this in my calculator and see it. But basically, since it's to a fractional power and my number on top, the 6 is even, that means this can become positive 1. So this is minus 5/6. Over here, these zeros drop away. So 1 to any power is 1 times 5/6 is 5/6. 1 squared is 1 times 1/2 becomes 1/2, so we got minus 1/2. If you got negative out in front, that flips the sign of everything inside, so this becomes a negative 1/2 plus 5/6. And I'll drop the parentheses around my second part here. 5/6 minus 1/2. Well, 5/6 plus 5/6 is 10/6. Negative 1/2 gives us negative 1. That gives us 5/3 minus 1, which is 5/3 minus 3 over 3, which gives us 2/3 for our answer. And I'm not going to plug that in the calculator. It's kind of more of a pain than anything. I could probably choose this first one, just multiply it by 2. Let's do that just for fun. Okay, press Y equals, press clear, clear out Y2 also. And I'll put 2, and then times x minus the 5th root. So I do 5, choose math, choose the one with an x, number 5. The beginning parentheses, x, and you don't have to put closing parentheses at the very end on the calculator. Second trace, choose intersect. Choose the 7th one, or integral. And what did I say? From negative 1 to 0. So negative 1, inner, 0, inner. 0.6667. Of course, they got some rounding errors, some approximation issues there. Now, my calculator is not set back to the normal zoom. To do that, to fix your calculator, press zoom and choose number 6 for Z standard. That'll set it back to your standard viewing window, if you're following along with this. Let me save this. There we go. Let's look at our next problem. We got y is equal to x squared plus 6x. And we got y is equal to 5x plus 6. First off, we want to find our points of intersection. So we're going to set the 2 equal to each other and then solve it. So we got x squared plus 6x equals 5x plus 6. Well, we've got a quadratic, so we want to get everything over one side and 0 on the other. So I'll take 5x plus 6, move them both to the left side, changing their sign as we do. So we've got x squared plus 6x minus 5x minus 6 equals 0, which gives us x squared. 6x minus 5x is x minus 6 equal to 0. And this factors as x plus 3 times x minus 2. Zero factor property. You get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set x plus 3 equal to 0 and x minus 2 equal to 0. And we get x equals negative 3 and x is equal to positive 2. Okay, well, let's graph this and see if that looks right. Very quick check you can do to verify that. Just graph them. See if they look like they intersect there. So on y1, I'll put x squared plus 6x. So x squared plus 6x. Down arrow to y2, and on y2 I want 5x plus 6. You may have to press clear to clear out whatever's on that line if you have something there. And then press graph. Here's our first one, our x squared, and there's our second one. -3 and 2. Can't see the top part, but I assume that's probably correct. Looks reasonable anyway. So I'll go from -3 to 2. It looks like from -3 to 2, this line is up on above. Line is the 5x plus 6. So this is above, minus the one that's below, which is the x squared plus 6x and dx. Yeah, looks good. Okay, so then we have 5x plus 6. Negative out in front flips the sign of everything, so it becomes a negative x squared minus 6x dx, which gives us negative x squared. 5x minus 6x is minus x plus 6 dx. And so then we'll add 1 to our power, divide by our new power. So that gives us negative 1/3 x to the third minus 1/2 x squared plus 6x. And now we're ready to plug in our numbers. So I got negative 1/3, 2 to the third, minus 1/2, 2 squared, plus 6 times 2, minus negative 1/3 times negative 3 to the third, minus 1/2, negative 3 squared, plus 6 times negative 3. Two to the third is 8 times negative 1/3 gives us negative 8/3. 2 squared is 4. Divide by 2 is 2 minus 2. 6 times 2 is 12. Minus negative 3 to the third power is negative 27. Negative times a negative is positive. 27 divided by 3 is 9. Negative 3 squared is 9 times a negative 1/2 gives us negative 9/2. 6 times negative 3 is negative 18. That gives us negative 8/3. Negative 2 plus 12 is 10. Minus 9 minus 18 is negative 9 minus 9/2. Which gives us negative 8/3 plus 10 plus 9 minus 9/2. Remember, our negative out in front flips the sign of everything, which would help if I actually flipped the sign. The negative 9/2 should be a positive 9/2. I was thinking I wasn't going to check this one, but I think I got better after that. 10 plus 9 is 19 minus 8/3 plus 9/2. I'm going to get a common denominator here, which would be 6. So multiply the bottom part by 2, multiply the top part by 2. Here I multiply the bottom part by 3, multiply the top part by 3. Um, 27 minus 16 is 11. So plus 11, 6. Get a common denominator. Okay, 4, 5. Boy, I'm drawing a blank here. Can't do basic math. That's bad. Multiply the bottom part by 6, multiply the top part by 6, so 19 times 6. 114. Okay. And then add those together, that gives us 125, 6. Assuming I did my basic math right, which is getting kind of iffy there. Let's check this. I'm going to come back up here. I'm going to plug this one in. Hopefully I'm getting down to that point. Press Y equals, press clear. I got to clear out Y2 also. Okay, so on Y1, we're going to put negative x squared minus x plus 6. And do second trace, choose my integral, number 7. Press the number in front, quickly chooses it. And we want from negative 3 to 2. So negative 3 for lower limit, inner, and 2 for upper limit. 20.833. Yeah, that looks reasonable. So, let me save that. Okay. Let me grab a drink here and we'll look at our last problem. Okay, this says find a consumer and producer surpluses by using the demand and supply functions, where P is the price in dollars and X is the number of units in millions. Now our demand function here is P is equal to 200 minus X, and our supply function is P is equal to 90 plus X. Now I put a hint down here. To find the price, you set the demand equal to the supply and solve, and then plug this X into either formula to find P, and then you're going to do these setups down here. So let's start with that. So I'm going to set demand equal to supply. So we got 200 minus X equals 90 plus X. Okay, so I'm going to get everything with an X on one side, numbers on the other. So I'll take the negative X over there, take the 90 over there. So I get 200 minus 90 equals X plus X. Gives us 110 equal 2X. Divide both sides by 2. Is that 55? So we get X equals 55. Now that X we just found there is also what we're going to plug in the integration here. See the X for the upper limit? That's what we're going to put there. This is 55. And, okay. So then it says plug this into either formula to find P. Well, P, I'll choose this one, 90 plus X. So P is equal to 90 plus X. And we just said X was 55, sorry. So that gives us 145. So that's our price. Okay, so our consumer surplus. I just put CS for consumer surplus. It says it's going to go from 0 to X. So 0 and X we said was 55. And then our demand function goes first, which was 200 minus X. Minus, and then our price. Price was 145 dx. Okay, so let's do this first. So 0 to 55, we got 200 minus X minus 145 dx. 0 to 55, we got negative X. 200 minus 145 is 55, I believe, dx. Add 1 to our power, divide by our new power, so we got negative 1/2 X squared, and then 55 just becomes 55X. And now we're ready to plug in our numbers. Now, note if I plug in 0, it just drops away. I'm going to put it there just so I'm not being lazy, but you don't have to when you're working problems. So we got negative 1/2 55 squared plus 55 times 55 minus negative 1/2 times 0 squared plus 55 times 0. I'm not going to work that hard. I'm going to plug that in my calculator. Second mode, negative 1 divided by 2 times 55 squared plus 55 times 55. That gives us 1512 and 50 cents. So that's our consumer surplus. Assuming I didn't screw up my basic math, which is always kind of iffy. Okay, our producer surplus. Let's say PS. Is going to go from 0 to X. And what did we say X was? 55, I think? 55, yeah. And then price, which we said was 145. So 145 minus, and our supply function, which was 90 plus X. dx. Okay. 0 to 55, and then we'll have 145. Remember, a negative in front of the parentheses flips sign everything. So it becomes a negative 90 minus X dx. So we got negative X, 145 minus 90, was that 55 again? dx. That one actually matches, doesn't it? Which implies, if it does it match exactly? It does. Which implies I don't have to even do the rest of it. This is going to be the same value. Now, I'll be honest with you, I haven't done enough of these to know if that's always true. But it's definitely true in this one. Sometimes when I make up numbers, which is what I did here, I make them up and I try to be random, but it doesn't come out that way. But anyway, you see the setup anyway, and how to go through it all. So let me save that page. That's assuming my brain isn't shutting down. I'm not making some major mistake, which sometimes does happen. I won't deny that. Okay. So let me stop the recorder.